Welcome everyone to part 6 of the Sci-Fi first-person tutorial series. In this video, we will be setting up quite a few custom events. We'll be completing our damage event in our master FPS character blueprint, create a death event, a despawn event, and start our own game over event. We'll also work on our character ragdolling when the death event is called by setting up a physics asset for our skeletal mesh. There's a lot to cover in this video, so it will be a little more fast-paced than previous videos, especially when we're covering a topic that we've already gone over in previous videos. So let's start off with our damage event. If you'll recall, inside of our projectile blueprint, we call an event named Apply Damage when this projectile hits our master FPS character or any children of that blueprint. We'll need to define what this event does inside of our master FPS character. So let's go ahead and open our BP master FPS character and move to the event graph. Let's scroll down just to give ourselves a little bit of space, right click, and we can search for event any damage. And this is the same event that's called from our projectile, so anything attached to this execute will be called and fired whenever we're hit by a projectile. The first thing that we'll want to do is make sure our character is alive before we deal any damage, since we don't want to be wasting any resources dealing damage to a dead character or risk calling a game over function more than once. We'll do this the same way we do for firing our weapon, and that's by using the isAlive function. So go ahead and drag that out onto the event graph. And let's plug the output into a branch. We may also want to add another check for debugging purposes to see if we're currently immortal. This will help us play the game without failing over and over while playtesting. To easily set up being immortal, all we have to do is simply set up a Boolean variable, and we can call it immortal ? Compile and save, and we'll want the default value to be false by default since we don't want to be immortal by default. And we can put this variable inside of the character parameters category just by dragging and dropping. While we're doing that, we can make it instance editable in case we want to make an enemy or an ally immortal at a later time. Now we need to ensure that not only are we alive in order to take damage, but we'll also need to not be immortal. To do that, we can get our immortal boolean, drag that into the event graph, and off of it we'll choose a not node, so we check to see if we're not immortal. And we'll want to make sure that both of these conditions are set to true. So we'll drag off of alive, search for an AND boolean, and plug the not into the and the output of the and into the branch. Now we can move these back just to give ourselves a little bit of space. Compile and save. Now whenever we receive damage, we'll check to make sure that we are not immortal and that isAlive is set to true in order to fire off of the true path. In fact, let's create some quick debugging input to become immortal. We'll need to return to our input graph here on the top and scroll down to give ourselves a little bit of space. And off of whatever keyboard press you'd like, I'll be using keyboard press F. Let's flip-flop between two executes. Search for a flip-flop node and plug that into the pressed for F. Here we can set our immortal variable based on whether or not we're executing with the A pin. So let's pull our immortal variable off, select set immortal, and plug it into the A pin. In fact, we can also plug it into the B pin, and we'll determine whether we're setting it to true or false based off of this is A. So if we are going to the A pin, it's going to be true since we are using A. If we're going through the B pin, it'll be false since we're not using A. If you don't know how a flip-flop node works, basically every time you fire it, it's going to use the alternate execute. The first time it'll always default to A, then the next time you fire it, it'll use B. And it'll continue alternating back and forth every time you call it. So we'll want a visual indicator to know if we are currently immortal or not. So let's go ahead and right-click, choose print string. It's a very handy tool to just quickly print what is happening on the top left of the screen during play. And off of the in string, we're going to select a string, and that string will be determined on whether or not we are immortal. So A will be true and B will be false based on this boolean. Pick A. If it is A, we're going to type in immortal, and if it's B, we're going to type in mortal, so that displays on the screen whenever we play this flip-flop. This quick debugging script will allow us to easily flip-flop the immortal variable and display its status on screen with this simple print string. We can display this if we play in editor and hit F over and over. We can see that we're flip-flopping over and over on the top left. Now let's go back to our event any damage. We'll need to go back to the event graph and scroll down. If both of these conditions are met, which means we'll fire off the true path, then we'll need to actually lower our health value, aka deal damage to our character. To do this, we should get our current health variable, which is our float value, and we'll subtract this value by a float, which is equal to the incoming damage. And then we'll set our health variable to the output of this calculation. So let's drag out set health, plug that into the true path, and plug in the calculation. So whatever our health was, we're going to subtract it by a little bit and set our health to that lower value. We'll then need to check if we're dead or not. So we'll need to check to see if this new value is less than or equal to 0, because if our health is 0 or less, we'll need to additionally call our death function. And if not, we won't need to do anything after taking damage. So let's drag off of the health value, search for a less than or equal to float, and off of that, do a branch. So this will check to see if our health is less than or equal to this value here, which we're going to keep as 0. If this value is true, we'll want to call our death function. So let's make a custom event called Character Death. That way we can call this event at the end here off of the true path. So we'll call Character Death, which is the custom event that we just created just a moment ago, and everything off of this execute will happen if this is true. We could have used a function instead of a custom event here, but I'm going to continue using custom events for the remainder of this tutorial series in regards to damage, just to stay consistent. And that's really all we need to have happen whenever we take damage, since if we're not dead, we'll simply just subtract health and do nothing afterwards if, we're still alive. Luckily with this setup, we can always add more functionality off of the false path or after the character dies in case we want to do that in the future. But for now, this works for taking damage. Next, let's work on what happens when a character dies, and this is entirely up to you, but what I decided and what I thought would be fun would just to have a character ragdoll when they die. We'll be doing this exactly how we set it up last year in the video UE4 Character Damage and Death. In order to begin ragdolling, we'll need to get our player mesh component from our components tab. So let's drag that into the event graph. And from this component, what we'll want to call is set all bodies simulate physics here on the bottom. And we'll want to set this to true so that every bone in our body will begin simulating physics. And this alone will begin our ragdolling, but our player mesh's collision settings are set to the improper presets. If we go to the player mesh in the details panel and scroll down, we can go to the collision settings, and currently it's set to character mesh. With these presets, unfortunately, it ignores a few different types of collisions, which means that we fall through a lot of types of surfaces. So let's change the player mesh's collision preset to something a little more useful like block all dynamic, and compile and save. At this point, if we test our functionality by putting another master FPS character into the level and selecting play, we run into 3 problems. The first and most apparent problem is that the character that we've dragged into the level isn't visible for us, and you would have run into this issue in previous videos as well, since we didn't change one setting. And let's change that right now. Let's go back to our master FPS character, and for our player mesh, There was one setting that was set in our first person template for our skeletal mesh that we never ended up changing back to normal. Of course, when we started, it was just a simple pair of floating arms, and there was only supposed to be one of these blueprints in play at the time, but we've changed it significantly. So what we'll need to do is scroll down to the rendering tab inside the details panel for our player mesh, expand to show advanced, and this value that is set to true, only owner see, we want to reset to false. That way anyone can see this blueprint regardless if it's the owner or not. Let's compile and save that and go back to playtest in the level. And now we can actually see the other character in the level when we play. However, when we kill them, we run into our second problem. They don't begin ragdolling. And if you check the debug, they are actually taking damage and they are actually dying. Let's do that really fast. Let's select them in the debug, minimize this here, and let's watch this value. To do that, all you have to do is right click on the output and select watch value. I'm going to shrink this down just a little bit so that we can still see it while we're playing. Put this down here and let's play in the editor so we can see that their health is lowering 80%, 60%, 40%, 20%, etc. and they continue dying. Now we don't deal any more damage when they're already dead, but the problem is that they don't begin ragdolling. And the reason that this skeletal mesh is not ragdolling is because the skeletal mesh that we're using doesn't have a physics asset assigned to it. If you'll remember, when we imported these skeletal meshes, we didn't assign a physics asset to it. In fact, we deleted the physics asset that came with it. So inside of our master FPS character, let's go to our player mesh. And here on the mesh tab, we can go directly to the skeletal mesh in the content browser by clicking the magnifying glass and opening it in the content browser. Here we can see all of the asset details and the entire skeleton tree, but we're just going to stay on the asset details tab. And we'll want to scroll down to the physics section and assign a physics asset. Here we have the physics section, and what we'll do is assign the mannequin physics asset to this skeletal mesh and save. We chose the mannequin physics asset since it uses a full skeleton exactly like the skeletal mesh with the same bone structure and hierarchy. After saving, we should be able to go back into the editor and kill our character, and they should begin ragdolling, but we run into our third problem. The third issue is that our skeletal mesh is colliding with his own capsule component. We can see that the player mesh shot out from his capsule component. If we unpossess our character, let me minimize this, eject, and I'm going to select this guy, and we can see that the capsule component is over here. The player mesh component is way over here, so they split up quite a bit. If we repossess, you'll notice that I can shoot the bullet until it hits the capsule component, which is right here. Notice that the bullet isn't hitting the wall behind it, like over here. That's because the capsule component still has its physics in place, and that's why the player mesh jumped out from it, because they collided against each other and the player mesh lost. And I also noticed a fourth problem that I wasn't anticipating, where our less than or equal to check in our master FPS character, if we go to the event graph, this less than or equal to check is coming up false when our health is exactly 0. This is one of the issues with using float variables, where for some reason the values can sometimes end up very close to the displayed number, but behind the scenes they can be off by a very tiny margin. In our case, the displayed number is showing up as 0, as evidenced during play. If we shoot 5 times, the number is displaying 0 where we're watching the float value, but behind the scenes the real number is probably more like 0.0000000001. So technically, when it checks to see if the value is less than or equal to 0, it is greater than 0, which is kind of annoying. We have a couple different ways to fix this, though. We can either adjust the damage that our weapons do so that they do slightly more damage, Or we can have this check be slightly higher so that it checks to see if, you're at 0.01 health. But I don't like that. I want you to actually be dead when you die. So I'm going to end up changing the damage that my semi-automatic shot does by scrolling up here and changing the base damage to 0.21. And now we have our single shot definitely killing in 5 shots. 1, 2, 3, 4, 5. Now with that done, we can definitely fix our capsule collision problem simply by changing its collision settings when we die. So character death, we can change its settings. Let's drag out the capsule component, and off of this we can change the settings. So let's drag and search for set collision enabled, and we're going to set it to no collision. This will nullify all of its collisions, and that should set us up to nicely ragdoll. Let's play, shoot 5 times, 1, 2, 3, 4, 5, and our character is nicely ragdolling on the floor. But of course we run into another problem. If we shoot the character again, our projectile is applying way too much force to the ragdolling body. Or perhaps in your case, if you really want the body to fly off, not enough force. But we can easily change that in our projectile. So let's go back to environmental folder, open master projectile, and we can see the amount of impulse being applied to our character is getting our velocity and multiplying it by a value. We should multiply it by a smaller value than 100, so I'm going to change it to something like 15, compile and save. That way the ragdoll moves but doesn't fly across the entire universe when you shoot the body. What we could do if we wanted to give ourselves a little bit more freedom is set this to a variable, and we can call this variable force multiplier. In fact, I'm going to change the size variable to decal size, and we can make this instance editable and exposed on spawn. In our master FPS BP, we can go to our fire single projectile, refresh the node, and we'll plug in decal size into decal size. We'll have force multiplier be added as a pin with a default value of something like 15, like we set up earlier. And whenever we call this function, we can have the force multiplier change based on the type of firing mode that we're in. For a single shot, we can have it small, like 5. We can keep it at 15 for burst fire, and let's do something crazy like 45 for the automatic firing mode. Setting up something like this should be second nature at this point if you've been following the tutorial. And we can test out the force multiplier if we play in the level, kill our character, shoot him once when he's dead, and you could see that the single shot is doing barely anything. Let's switch to our automatic. That makes him fly a lot. And obviously our 3-round burst will make him fly quite a bit as well, as long as we're hitting him. Going back to our character death event, we'll want one thing to happen if our character's death causes a game over, and we'll want it to do another if it doesn't cause a game over. So let's create a boolean that we can call death causes game over, question mark. And we'll want the default value to, once again, be false, since we don't want every character's death to cause a game over. And let's make this variable instance editable in case we ever want to have an ally we need to keep alive or something. We can put this once again in the character parameters category, drag it off into the event graph, and get a branch, one of the most helpful nodes in Unreal Engine. If the character's death does cause a game over, we'll need to call event game over. So let's do what we did earlier, create a custom event, call it game over, and we can call that here off of the true path. Let's create another custom event called despawn. Custom event, despawn. Since if a character doesn't cause a game over, we don't want them to just be ragdolling on the ground indefinitely, since that does take up a little bit of resources and can get a little overwhelming if there's tons of bodies on the ground. We'll want them to despawn, and we'll call that off of the false path. And that's it for the character death event. Lastly, we'll just need to define the game over event and the despawn event. Let's do the game over first, since it's going to be really short, and we can really only start it since we don't have any game over widgets made yet. In a lot of games, when a game over happens, there is a slow time effect and a small delay before a game over screen pops up, and that's basically what we're going to do. We're going to quickly recreate that for our game over event. First, let's start with a global time dilation. Set global time dilation, plug that into the game over event. Now this is a really powerful node. With a global time dilation node, you can either slow down time or speed time up based on the values that you type in for the time dilation. For instance, 0.5 will slow time so that it goes by half as fast, and a value of 2.0 will double the speed of time. I'll be using something like 0.3 so that we get a nice slow time dilation. After the time dilation starts, we'll want to delay for just a split second, but remember that your delay will be affected by the time dilation. So if your time dilation is really low, you may end up waiting a very long time for your delay to finish. And I'm going to keep this value of 0.2 for the delay, that way we're not waiting super long. And that's really where we'll need to stop for the game over screen, since the next steps to create a widget and add that widget to the viewport can't really be done since we don't have a class of widget to select from. We can add these nodes here, but we can't connect the executes just quite yet until after we create the widget that's to be displayed for the game over event. And lastly, let's finish the video with the despawn event, which will likely be the most informative part of the video for beginners to Unreal Engine. When we call the despawn event, we'll want to wait just a little bit of time before the enemy despawns. Having a character despawn immediately when they die isn't that fun, since you're not able to play with their ragdoll at all, and it just seems really unconvincing. So let's wait about 5 seconds before the character despawns, or however long you'd like to wait before they despawn. Next, we could simply destroy the actor, plug that into the complete, compile and save. But when this happens, it's quite sudden, and it doesn't really feel right in game. For example, let's play test and kill our character, and after 5 seconds, he's just going to destroy himself. He just kind of disappears, which is really unsatisfying to me, but luckily there's an easy way to add a little bit more showmanship to this character before he disappears. And that is by shrinking him down into nothingness. I'm going to disconnect the destroy actor, but leave it on the event graph since eventually we do want to call it to destroy the actor. To shrink our character down to nothingness, we'll use something called a timeline. So right click and search for add timeline, add that to the event graph, and we can give it a nice name. Let's call it shrink character. And after the delay is completed, we'll want to play this animation or timeline from the start. Compile and save. Basically, a timeline is a makeshift curve editor where we can assign a length of time and have a value change based on what time it currently is on the timeline as the timeline plays. It's a little tough to explain, but as we do it, I think it'll become more apparent. Let's open the timeline, and what we'll need to do is create a new track, and this track will define how long the timeline is and how many variables are going to be changing throughout that course of time. We just want one variable to change over time, so we're going to be using a float track, which is just one value. And we can call this float track shrink track, just so that we have our naming conventions in place. Like any timeline, we'll need to specify how long the timeline is here and the length. And this one's going to be very short. We want them to shrink extremely quickly. So I'm going to set my timeline to a length of 0.2 seconds. Now we'll need to add 2 keyframes, or keys as they're called in timelines. And this will determine at what time the variable will be what value. We're going to right click, add a keyframe, and at time 0, we're going to have a value of 0. Let's add another keyframe, and at time 0.2, we'll have a value of 1. You can see that the curve is kind of going off screen. In order to zoom in and have it fit the horizontal, we'll choose this left option, and to have it fit vertically, we'll choose zoom to fit vertically. So as time passes, this float value will change from 0 all the way to 1. And that's going to happen in 1/5 of a second, 0.2 seconds. And if it's still not making sense, we'll see it in action here shortly. But I do want to add one touch of detail. I don't want our shrink to happen super linearly. We can add a bit of auto interpolation between these two values if we select the values with Control, right click, and click on Auto Key Interpolation. Now, instead of being a super linear change, it's going to slowly start to shrink, and then at the end it's going to slowly stop shrinking. Even though the shrink happens so fast, this should give us just a slightly better looking shrink. Now we can exit the timeline, go back to the event graph, and we have the shrink track float here as an output for the timeline. And to actually shrink our character, we'll want to drag our player mesh onto the event graph, and we'll want to do something called Set World Scale 3D. We'll plug this into the update execute, and we'll have to tell the engine what scale we want to start at and what scale we want to end at. To do that, we'll have to drag off of the scale and linearly interpolate or lerp from two vectors. Now these values here should look familiar. If you go to player mesh, the scale is also set up as a vector. And the two scales that we're going to linearly interpolate from are A being our default size of 1, 1, 1, and B the shrinked size, which is going to be 0, 0, 0. Now, a linear interpolation or a lerp requires something called an alpha, which is a float value. If the value of the float is 0, the scale will be A. If the alpha is 1, the scale will be B. If the alpha is anything in between, it will be something in between A and B, and it will linearly interpolate that vector. So if we plug in our shrink track into the alpha, the timeline will change our size based on the float value. And when the timeline is finished, we can simply destroy our actor. It's nice to see it in action, so let's go and play in the editor, kill our guy, wait 5 seconds, and he'll shrink very quickly. Nice. If we make the timeline longer, something like 10 seconds, I'll choose my second keyframe and I'll put this at 10 seconds, compile and save. The same thing is going to happen, it's just going to happen much slower over the course of 10 seconds. You can see him slowly shrinking, getting thinner and thinner until he goes out of existence. It's actually kind of freaky. Yeah, that looks kind of freaky, which is why the quick shrinking is much better in our case. Hopefully that helps you understand timelines a little bit better. I'm going to change my keyframe back to its normal time, 0.2 seconds. Compile and save. And that should work wonderfully. But yeah, timelines are very useful for changing values of floats and vectors over time. You can use them in a myriad of ways. Just try them out and they're super, super helpful. Well, that leaves us in a great place to end the video and take a little bit of break since we've done so much. In the next video, we'll create some child classes for our Master FPS character and work on getting our enemy to attack us with some simple prototype AI. Thank you so much for checking out the video. I really hope you learned something. I love making these videos, so I want to thank you for watching it. If you want to leave a like, a comment, or a subscription, it helps me out immensely and I would be very appreciative. I'm Joe Von D, here to help you think like a game developer. Stick around for the next video in the tutorial series.